What is nature's remedy for burns and wounds? Hello! I'm Philip and this is Mastering Shells. Last time we talked about Vim and how we can navigate and write files and read from them. But today we're going to talk about something very classically shell related for POSIX shells. We're going to talk about piping, redirecting of inputs and outputs. But before we can talk about any of this, we need to talk about how programs, applications interact with the shell and with other applications in a POSIX style system. I hope I have some graphics for this. Let's imagine this is an application. If this application has a command line interface, then it has 2 inputs, 3 outputs. The 2 inputs, one of them we already talked about, arguments. Command line arguments are a way to hand in pieces of information at the startup of a program. Second input is what's referred to as standard input. This is input that the user gives to the program while it is running. There's an output called standard output, standard error, and a return value. Return value is basically just a number that allows the operating system to know if the call to this application was successful or not. If the return value is 0, that means the program executed successfully. If the value is anything other than 0, that means the program had an error code. And this return value is also that very error code. Today we're going to be focused very much on standard input, standard output, and standard error. Okay, let's imagine our program here. We have started our program with our command line arguments. And while the program is running, standard input gets read for new data to come in. This data can then be processed somehow, something is done with it, and then there's 2 ways to output information. Standard output is the default output for any form of information that the program outputs. This was written to standard output, and then the shell, the terminal, read this and printed it for us. Standard error is if we create an error and the program wants to write an error. If we want to move into this folder, this, for example, was written to standard error. And we'll see the difference soon enough. Both of them get written to the screen right now, but that's not always going to happen. Let's look at the specific differences. Okay, let's use ls for this example. We're also going to use a pipe, but first let's, for example, echo. Echo is a program that just prints back on the screen what it read, but it can also print variables. For example, if we print our current path, again, this is a variable called pwd that actually contains the same value as pwd, the print working directory program. And so this variable can be printed and can be dereferenced with the $ in an sh-like shell. Okay, but there's no standard input happening here. What we could do is read. Now we're reading values. Read. So this just read input from standard input. Let's look here. Read a line from standard input and split into fields. So read variable 1. This is the text going into variable 1. And now, if we print variable 1, you can see we had written this text into variable 1. Variable 1 now has this. With unset, we can unset this text. And if this text is now unset, you can see now variable 1 is empty. But we can read something into it, new text, and then we are printing, and we are printing to standard output. And you can see now the variable contains the value variable 1. Now variable 1 contains the text, new text. Okay, so now we understand standard input is what the program reads while it is running. Standard output is what it's outputting while it's running, and standard error is where it prints errors while it's running. The reason this was really important for us to understand is because of this operator, the pipe operator. The reason this is called pipe operator, because like a pipe, it can connect different programs and allow information to flow from one program to another program. Let me show you. Okay, let's start here. Let's go into a folder. Let's go into our folder from last video. We have a few files in here. We can print with cat. We can look at Vim instructions, new. This is the instructions we wrote for Vim. Okay, so we have our Vim instructions with different lines. And now we're gonna pipe this, instead of writing it to the screen, we're gonna pipe this into another program called grep, Global Regular Expression Print. Basically, it allows you to take input from read standard input, find patterns in that input, and then print only the lines that have that pattern, or only print that pattern. For example, if we only want to find lines that have yank in it, grep yank, and now you can see while we catted this whole file was now passed 1 byte at a time to grep. Grep then read this input 1 line at a time, because that's how grep works, not because of piping. Piping always passes in just pure byte streams. But grep reads 1 line at a time, by default, can be changed. And then changes the word yank. This is -I, very useful, is for let's go for example, grep V. You can see visual. Grep -I is I can't remember what it stands for. Is ignore case. I is minus ignore case. And you can see before V only used lowercase v. With -I, it ignores the case. So lowercase and uppercase. So for example, capital V is only in a single line. But if we have -I, capital K, V, then all the lowercase v's also come back. Okay, so ls prints these files. ls can also be put into this grep. And now we want to find only files that are called Vim. And you can see each element here gets processed as one element by grep. And we can find files that have the word Vim in it. But grep, we're gonna do a video about grep in the future, I'm sure. Grep is very powerful. Let's go back to Vim instructions, new. We're gonna grep that into Vim. Actually, do you know what we're gonna look at? PS. PS does not explain a lot, okay? PS is a process monitor. It basically shows which processes are currently running. PS -U. And now this is a lot of information. So what I can do is I can grep this for Python processes. Okay, so pipes can continuously be connected. For example, let's go cat vim our instructions again, and we put them into word count. minus L, there are 26 lines in Vim instructions. So let's check if that is correct. Every time set number. There are indeed exactly 26 lines. Now we're gonna add a line. I'm gonna run this command again. Now we can see there are 7 lines in this. But if in between we grab this for V and then push this into word count, now there's only 6 lines with the character V in it. So a pipe essentially allows you to connect one program's standard output to the standard input of another program. And this is where the POSIX standard becomes so powerful, because this chaining of different commands allows you to create very powerful shell scripts where programs work together, and this clear interface of just a byte stream and the next program can read that is very, very useful. But we're going to talk about more than just piping. So this is essentially a pipe, and we're going to use this a lot going forward. Okay, so standard input comes in, especially when running scripts. We want to, standard input comes from somewhere, usually a cat of some kind or an ls or ps or whatever program generates the original content gets piped forward and forward and forward and forward. Instead of using cat like this, we could also directly pipe grep v with the lower than character. We can also redirect directly a file into standard input. This is what this does, because it points into grep. This after the command, this has to be written after the command. There's a few commands. Okay, so there's this command which redirects standard input into a program, and then the output is standard output. That would be the other one. In particular, this would be standard output. This would be standard error, and we're going to look at this and those differences. But let's go one step at a time. Vim instructions new, and you can see we're reading this file, but this time we didn't have to cut it. All we had to do was pass this file as standard input. This is what this character means essentially, because it looks like an arrow pointing into the program. So this file here, Vim instructions new, gets pushed into grep v. Equally, the analog would be taking the standard output. This is pointing out of the program, and we're putting that into grepped output.log. Oh, we need to obviously connect some standard input. You see it printed nothing, but we can now print grepped output, and it wrote into a file grepped output. Instead of printing to the screen, grep this time, we've redirected the output of grep v into a file. We gave a file descriptor, and it ended up in that file. We can also combine them. So we want to write to grepped output 2, which doesn't exist, by the way, just to be sure. Grepped output 2 doesn't exist. Grep v, grepped output 2.log, and we want to read from grepped output log this time. But this time we'll pass in only lines that have visual in it. Again, nothing was written to the screen because we've output everything to grepped log 2. And if everything went correctly, then we should see grepped output 2 has only the lines with the word visual in it. So we read from this file and we output into this file. Now Let's see if we can break something. Okay. So now we're trying to write to a folder. We're trying to create a file. Now we've given our standard output a file descriptor that is in a folder that doesn't exist yet. You can see there's only files in here. There's no folder called test. And so when we try to write a file inside the folder test, we're getting an error. No such file or directory. Note, we got the error printed on the screen. This error didn't end up in a file. This didn't go anywhere because we only redirected standard output. And this is where the difference between standard output and standard error come in now. So standard error is still connected to our terminal screen, and that's why we're getting errors printed to the screen. Let's the way we're connecting a different one. So let's standard output, and with 2, which is our second output, standard error, let's write that to grep error log. Oh, because we're redirecting before we redirected. So first we need to redirect error log, and then if we get an error, because our error happened here, which was before we even reconnected error log. So this error appeared when our shell tried to connect grep standard output to a file that doesn't exist. So this, I believe, should work now. Please don't embarrass me. Perfect. Okay, so now you see we did not get an error written anymore, but we got an error log. So if we now cut our error log, you can see this was written. Okay, so order is important. Where's our last command? There it is. First, connect your output, error log. First, connect your error. But what if I want to connect them to the same program? What if I want to write everything to the same file? Well, we can also do that. So let's just cat, for simplicity, vim instructions new, and we want to redirect this and with the ampersand. This ampersand, this and symbol, means that the next input is not a file descriptor, but actually a file handle number. In our case, 1, which is, as we know, so if I do this and I try to read a file that doesn't exist, you can see it generated a file that is called 1. And this file has our error message because we redirected the error into a file called called 1. But with this ampersand, this means that 1 is not a file descriptor or the name of a file, but actually a file handle. In our case, file handle 1, which is standard output. And now you can see it was printed to the screen because we directed standard error to the same handle that standard output is here, which is our screen. But if we redirect 1 first into, STDOUT STDERR .log, now you see our error message did not appear anywhere. But we got this file, and if we cut std out, now our error ended in here. But if we read a file that is valid, we also get no screen. And this time, if we cut this time we got the official standard output. So with 2 redirect, the redirection of 2, standard error gets redirected into the location that currently 1 is pointing to, standard output. In modern shells, luckily there's a simplified syntax for this. So if you use bash or ZSH or most modern shells, you can simply go ampersand point, and this means both of mine should point to std out error log. Okay, but there's one more thing. What if I have a log that I want to continuously write to? Let's create an array and then map file -t files. Now we're redirecting the output of ls, reading that and putting that into map files. Now if we echo files, we actually see only the first file because we need to, this is actually a real array in bash. We need to print all of them, and you can see there's all the files. This is how you dereference arrays, and this is just printing the whole array. Okay, so now for file in files, do echo file done. So now we can see for each file, we're printing file. Let's print this. So you can see it gets iterated for each file, and you can see actually here, this is not just one ls log, actually each file is its own element because we used map file. Up here, map file. This basically uses every line and maps a whole file. Each line gets turned into one element in that array. And this array files now contains our files. Now that we have the files in here, what we can do is, for each file, we want to cat the file. And now you can see we're printing all the different files. And this is a long one because it has 1,000 lines. And for each file, we want to cat it. And once we cat it, we want to grep visual. And now we can see there's a lot of lines. And we want to echo, before we cat it, we want to echo the file name. And then cat it. Okay, so we got a few files here. We got grep error log, had nothing in it. Grep error. Maybe we'll do this a bit nicer. Okay, so now we can see grep error log didn't have any visuals in it. Grep log did have some visual in it. Okay, now let's write this to a file, right? We want to write this out, directed to a file called visuals.log. Okay, now you can see we didn't direct the echo actually. So let's do that by wrapping this up in a subshell and collecting the. Okay, so now just to be clear, we've wrapped this up in a subshell. That subshell echoes each file, within echoes the file, and then cats it and grabs the word visual on it and outputs it into visual log. Let's do that. We've pushed everything. Let's look at our visual log. That's not what we wanted, was it? Vim instructions. Why are we only getting Vim instructions? Well, it's because every single time we're iterating through these files, we're outputting to visuals, and this is the overwrite redirect. What we should do instead is greater than, which is appending. Okay, so if we do this now, and then we cat this, you can see we're starting now with visuals because that's what we had before. And then we see each time we append to the bottom of it. So if I run this again, now you can see we have a lot of files because we added to this on constantly. So instead we'll remove this file, and then we write to it. Now you can see we cleanly get our file. Okay, so we can redirect, overwrite. So this just, whatever's on the file, eliminates it and writes over it. This will allow us to append to an existing file if it exists, but if it does not exist, it will start it. This allows us to take a file and connect it to standard input. This redirects standard output. This redirects standard error. In modern shells like bash and ZSH, this connects both standard output and standard error to a file, and a pipe connects the standard output of one program to the standard input of another program. I'm going to show you one more program that is nice to have. We're going to cat vim instructions, and we're going to pipe this into T. So our pipes connect straight one end. There's just one hole in a pipe. Things go in one side, things come out the other. Data goes into one side and the same data comes out the other side. T, imagine a T-junction at here now, where I want to write into my file vim instructions copy.txt. So now we're reading this catted file, we're putting it into T, and T does one thing, it prints it, but also created it to a file. So rather than, it's like a redirect, but it also keeps it on standard output. It copies the output. So if we look into vim instructions copy, you can see the content is also here. Now, this is not very commonly done, but you could actually take the T output and pipe it further because it is connected to standard output. And then we can grab this output for visual, and you can see it works. But the T created a little T junction where we also wrote to the file. So vim instructions actually still has the full file, because we teed off right here. So whatever was pushed through here was then fed down to the file, but also fed forward to grep, and grep then made it smaller. You could use T, for example, to extract data from within a pipe to see what the data looks like in that pipe and write that to a test file. Really useful. And I think that's where we want to leave it for today. We've gone through a lot, and I hope it was useful. If you enjoyed it, please press like, subscribe, and I'll see you next time.